Welcome back to the Ubuntu server series here at CBT Nuggets. Today we're talking about one of my favorite topics in the whole wide world, coffee. No, wait, we're talking about networking, although I do enjoy coffee very, very much. Today we're talking about networking. We're going to cover a couple different topics. We're going to cover static configuration, because by default when you install Ubuntu, it uses DHCP to get its address, which is great, except for servers. Generally, you want to have a static configuration. So we're going to check out static configuration. I want to talk about the crazy new DNS stuff that Ubuntu is doing with ResolveConf. If you've been using Linux for a while, you need to know that as of 12.04, you can't just simply put your DNS information into resolve.conf in the etc folder. It doesn't work. So I'm going to talk briefly about this, show you how we do set it up now, and then we're going to finish out the nugget by bonding interfaces. I've drawn a nice little 1U server here, and I don't want any emails about my drawing skills. But the reason that I wanted to draw this is because most servers come with these two Ethernet ports. Now, if you thought that those were tanks from Atari's Combat, you were wrong. Those are supposed to be Ethernet ports. And if you have two on a server, you might as well be using both of them. And that's where bonding comes into play. Bonding does two things. It can provide load balancing, and it can provide fault tolerance. I'm going to just concentrate on a couple different ways that we can set up bonding depending on what your switch supports. You can do bonding whether your switch supports bonding or if it doesn't directly support bonding. We can do it even if it doesn't support it with Linux. So we're going to get use out of both of those Ethernet ports that are in your 1U rack mount server. But first things first, let's go to our server and configure the Ethernet port. So before we connect to the Ubuntu server, I just want to point out that in a desktop environment like this, like Xubuntu or the Ubuntu desktop, the network is going to be configured with the network manager up here in the corner. So you edit the information with this little GUI tool in here. This is not what you do on a server because there's no GUI and the network manager is not installed. Okay, but if you're on the desktop and you're wondering why it doesn't work the same, it's because the network manager is installed, and that's what handles the networking. For the server, which is what we're focusing on in this series, it's done with configuration files. Now, unfortunately, I already had to configure static networking so that we'd be able to connect to the server like we are just by clicking the host and SSHing into it. So we don't have a default system with DHCP as the default setup. So what I did before I made the static changes is I copied that etc network interfaces file. I copied it to my local directory here. So let's look at it. This is what's going to be by default in etc network interfaces. So that file is what we're looking at right now, the file, or what's in that file by default. And basically it sets up two interfaces, and there's even comments. The loopback network interface, which is LO, you may be familiar with loopback 127.0.0.1. Basically, it's set up like an Ethernet interface that you can only access from the local machine. So if that's unfamiliar to you, just know that this is where the local loopback interface is set up. And then the primary network interface. Now, this virtual server that we have right now only has one Ethernet card installed into it, and it's ETH0. So by default, it says iFace or interface ETH0 iNet DHCP. So that's the default setup for getting the interfaces configured. It uses DHCP. You'll notice that this top line here, auto, LO, and ETH0, this is saying that it's automatically bringing up both of these two interfaces. Sometimes you'll see each one in its own stanza, and this works just the same as well. Sometimes it's easier to tell what's going on if you do it that way. Either way works perfectly fine and works the same. So auto LO automatically brings up the local host, and auto ETH0 automatically brings up ETH0, and this is the configuration. Now, in order to make this a statically assigned address, we have to change this etc network interfaces file, and we're going to do that right now. We're going to look at the one that's already here. So that was the default one. Network interfaces. And so this should look familiar, right? This looks a lot like the interfaces that we had set up, especially localhost, auto, LO, iFace, loopback. So this is set up. The primary network interface is still auto ETH0. It automatically brings it up, so it's going to automatically enable on boot Ethernet 0. But here is where it changes. We still get iFace for interface, ETH0, iNet, but instead of DHCP, we say static, which means we're going to fill in the information on how the addressing works for this particular interface. And these are the lines. Now, unfortunately, these aren't in here by default. You just need to know these or memorize these or look these up as you're configuring your interface. And basically, you say the address, and then you put the internet address. Net mask, sometimes also referred to as subnet mask. So if subnet mask makes more sense, but net mask is actually the key syntax you need to have here. Gateway. It's just defining the gateway that the computer uses. If you leave this out, it's fine. You just don't have the default route to get out of your network, right? So if you don't assign this here, you just don't have a route out of your network. So gateway, this is the gateway on my local network. And here's where things get a little bit different and new. I mentioned briefly that there's some craziness with the DNS configurations starting with Ubuntu 12.04, and I'm going to look at the resolve.conf file in a second, but this is now where you add DNS information. If you're new to Linux, I'm sure you're saying, well, of course this is where you add DNS information. You're configuring your network interface. Why wouldn't you put the DNS information in there? Yes, I know it makes sense, but for years and years, this is not where you would enter DNS information. So it's hard for some of us who are old and crusty to get used to the idea. But it does make sense, and so here is where you put the information. DNS-name servers, plural, because you can put a whole list of them here. And then DNS-search, the search domain. So what the search domain is, let's say that I just try to ping Xubuntu. Well, it's going to try to ping Xubuntu.nuggetlab.com, and that's just going to be the default search path that it does if I don't put the entire fully qualified domain name. You don't have to have DNS-search here. You don't have to have this in your etc. network interfaces file. It'll work fine without it, but that's what this does. It allows you to have a search domain so that if you just enter a single host name, it'll search in this domain for it. And then again, the name servers, you can put one or more name servers on this list. Even if you have one, though, you do have to say name servers. That's important to realize, that you do have to have DNS-name servers. And that's all it is. You save the file, and you can restart networking. I actually recommend that when you change network settings, you reboot your computer, just to make sure that the changes you've made not only work, but will survive a reboot. Make sure that everything is configured correctly. I know that it is configured correctly because it's been working for us. You can type ifconfig and see the network interfaces. Sure enough, they're both up. And this one has that address that we assigned it with a proper subnet mask. It figured out the broadcast address based on the subnet mask. And there we go. If we type route, we can see that the default gateway was set. Using that gateway stanza in the thing. And then I actually want to look at the resolve.conf file. This is where you used to put name server information. So if you're an old school Linux person, this is where you would enter your DNS server information. You wouldn't put it in that etc. network interfaces file. You would put name server and then another line, another name server, and another line, another name server. You still can edit this. However, you need to know that, yes, just like it warns here in all caps, your changes will be overwritten. Don't put your DNS information in there. The resolve.conf resolver does this automatically. It populates this file automatically on reboot and anytime there's a network change. And this is to make it more compatible for when computers change from network to network and their DNS servers would change. But basically, this is where you used to change information. You don't anymore. This is where the information is stored, but it's not put here by human hands now. It's put here automatically by resolve.conf, the daemon that controls DNS resolution. Okay, that's all there is to set up a static IP address. I mean, it really truly is that simple. You just need to remember those syntax things in the etc. network interfaces file, like network address and netmask and gateway and DNS-name servers and DNS-search if you want to have a search domain. And that leaves us just the one more thing to look at, which is a little more complicated, but it's not difficult. And since you're working with server here, I really recommend that we do look at how to bond interfaces. Now, before we go into bonding, I did make a slide just to reiterate the things about resolve.conf. Again, you may be thinking, Sean, this is not a big deal. I have no idea what resolve.conf is, but it's just important. It's such a drastic change in the way that we do things in the Linux world that I want to just reiterate on another slide that remember everything regarding DNS is now put into the etc network interfaces file along with the static IP information that we put in there for each interface. Do not edit. Do not edit that etc resolve.conf file. Even though that's the way you used to do it, it's not, you don't do it that way anymore. Resolve.conf program will overwrite it. And lastly, yes, of course, it does annoy me, mainly because I'm an old curmudgeon, and doggone it works fine when I used to have to walk uphill both ways to get to school and configure my DNS or something. Anyway, let's get to bonding, because bonding's really cool, and a lot of people don't do it just because they don't know that it's as simple as it is to configure, and they just have a wasted Ethernet port on their server, and that's just so sad. So bonding. There are actually 7 bonding modes in Linux, which I know just sounds crazy. How do you know which mode to use? But really you need to ask yourself one question. Do you feel lucky? No. The one question is, does my switch support 802.3 AD? Now this is the dynamic link aggregation standard set by the IEEE organization. So this is the standard for aggregating Ethernet ports together to form one link. If you have a managed layer 3 or better switch, it probably supports this. I think in the Cisco world this is called Ether Channel. Basically LACP. That's what you want to look for on your switch to see if you can configure ports to do 802.3 AD. If not, hey, don't worry. Linux has your back because it can do load balancing even if your switch doesn't support it. So if you just have like a desktop switch, which is what I have in my basement. Actually, it's rack mount, but it's just a dumb switch. There's no management to it at all. But I can still use Mode 6 or balanced ALB, adaptive load balancing, and that allows me to take advantage of port bonding in Linux even though my switch doesn't support it. I think maybe that's one of the reasons that people don't often use bonding is they don't realize that they can do it regardless of their switch. All right, so we're going to look at 2 modes basically. If your switch supports 802.3 AD, then you want to use mode 4, which is 802.3 AD. If your switch does not support 802.3 AD, then you want to use mode 6. Now, mode 6 will work regardless of your switch. There is one caveat. The only note to make here is that mode 6 does need your Linux driver for your Ethernet card to support MAC address changing. Now, almost every card that is compatible with Linux is going to have the ability for the kernel to change the MAC address on it. The best way to know this is to set up bonding, and if it just doesn't work, then you know that there's something wrong with your Ethernet card, but chances are it's going to work. I've never run into a situation where my kernel didn't support the ability to change the MAC address for a card on the fly. And that's what mode does. It uses some kind of magic where it constantly switches the MAC address back and forth to balance the traffic. The other thing this does, it's balanced-ALB. It does adaptive load balancing, but it also does fault tolerance. If one of those ports dies, the other one just picks up. So while it's actually called adaptive load balancing, and that's really nice, it also provides fault tolerance. So there's really no downside to using bonding with your Ethernet ports. It really is just the thing you want to do. So let's go to our command line to see how that's configured. Okay, since we're messing with the network interfaces on our server, we're back to the big old blocky ugly text version because we have to be logged in directly to our server. If we change network configuration while we're logged in via SSH, we're just going to get disconnected, and that won't do it all. So we're here logged into our server. I've actually added a second Ethernet card, a virtual Ethernet card to the server, but I haven't made any other changes. So we have to do a couple things. The first thing we have to do is install the software that allows for Ethernet bonding, and the name of that package is ifenslave. So interface enslave. So it downloaded it, it installed it, and it's all ready to go. The next thing we need to do is look to see if the kernel bonding module is loading when the system boots up. Now, modules that load on boot are listed in the etc modules file. And here we'll see it's not loaded. So what we need to do is add bonding. Okay, so bonding is now a module that is going to be loaded on our system every time it boots. Just like it says up top there, the file contains the names of kernel modules that should be loaded at boot time, 1 per line. So we've added bonding. We'll save that. Now we're going to edit that configuration file. Remember, etc. network interfaces. Here we are. This should look familiar, right? This is our network interfaces file that we were just configuring, but we're going to make some changes. Now I'm just going to make some room because we're actually going to reuse that because I don't want to retype it all over. But in order to configure bonding, we have to set up each Ethernet card as an Ethernet slave. And the way to do that is you start with the same way as before, auto ETH0, so it automatically starts up and activates the card when the system is booted up. iFace, ETH0, iNet, manual. Now this is different from static, okay? So iFace, ETH0, iNet, manual. Then we say bond, master, bond, 0. And that's all there is to configuring an Ethernet card to be part of a bonded interface. But we have to do the same thing for Ethernet 1, exactly the same thing. Okay, so now both interfaces are configured to be part of this bond 0 interface, and then the bond 0 interface is configured exactly like a regular old network interface. So we'll just say bonded now. And instead of auto ETH0, it's going to be auto bond 0. Not to be confused with the Autobahn, which is a really cool highway in Germany, but it's automatically going to bring up the bond 0 interface, which we've defined as the master bond for the other two Ethernet cards. So we change these things to bond 0. I actually want the address to be exactly the same. I don't want the actual visibility from the network to be any different. I want it to be all the same. So all of these things remain the same. However, since it's a bonded interface, I do need to add some things to specify the type of bond that it's going to be. Some of those things are, I'm going to make a space here, bond mode. Now we decided that we do not have an 802.3 AD switch here in my house office, in my home office, and also I don't think VMware supports it in their VMware workstation. So we're going to say bond mode 6 because I know that's going to work. Bond MIIMON. What this is the bond monitoring. How often does it monitor the individual links? And it's in milliseconds. So we're going to say every 100 milliseconds make sure both links are up. Bond slaves, none. This seems a little counterintuitive because we said the master is bond 0 up above, and now we're saying bond slaves, none. Well, each Ethernet interface, ETH0 and ETH1, bond themselves to bond 0. So we add this line. It's not trying to claim any slaves. The other ones are volunteering, I guess. Maybe that's a way to look at it. Anyway, this is all you need to do. This should be it. These are the steps required. So let's save this. And now we could just restart the networking protocol and make sure that the bonding module is loaded. I still recommend rebooting the server. And I recommend that because even if we could get it working, we want to make sure that when it boots back up, it's working like we expect it to work. We can see that the two Ethernet interfaces are up. However, our screen isn't big enough, so we're going to pipe it through more so we can see bond. Bond 0, the internet address there, iNet address, is set, so that looks like it's correct. And if we look, both Ethernet 0 and Ethernet 1 both have traffic going to them. So that means that it is load balancing because you see this is the total amount of traffic that's being done on the bond 0 interface. However, it's splitting it up nicely between the two different interfaces. So we can see that it's working. It's really a nice thing that we know not only are they up and running, but it's actually balancing the traffic that it's sending between the two different interfaces. If you want to actually test that, we'll just ping something. But we should actually say something whole, google.com, and it's going to ping it just fine. Now I could get fancy and disconnect one of the two interfaces. So right now I'm going to virtually unplug one of the cables. And bam, it said Ethernet 0, reset the adapter. However, our pings only hiccuped for a second, and now it's working. Let's re-enable it. And no hiccup whatsoever. See if it's back up. Both are back up and running. Up, up. Everything is working well. So that's bonding. See how simple it is? It's really not something to be afraid of. You should be using all of your Ethernet ports on your servers. You should be. It's really easy to set up even if your switch doesn't support 802.3 AD. If we did have that set up, we would just use mode 4 instead of mode 6, and functionally it would work exactly the same. Okay, let's make sure we got everything covered. My little slide here. To enable bonding, we install that ifenslave package, made sure that bonding was in the etc modules file. We configure the switch if needed. Now this is if you're using 802.3 AD. You might want to watch one of Jeremy's series or something on Cisco stuff as far as configuring your switches to support that. Then we edited our etc network interfaces file, and we changed it so that the ETH0 and ETH1 were both slave interfaces to that bond 0 interface. And then we rebooted. I really recommend rebooting. You see a lot of people say, oh, Linux is great, you never need to reboot. Well, I mean, that's often true. However, it's great to reboot to make sure that the changes you make are going to stick, and they're going to come up automatically when you reboot. It's embarrassing if you get it working, and then a week later, the server is rebooted and doesn't work, and you don't even remember why. What did you do? Why isn't it working? Anyway. Back at our first slide here with my fancy drawing of the back of a server. We set up static configuration for networking. We talked about that crazy new DNS stuff with ResolveConf that Ubuntu uses. You just know that you need to add this stuff to that etc network interfaces file instead of the resolve.conf file. Not a big deal, but it's important to know. And we finished up by bonding interfaces together. We didn't actually go through how to do it with switch support, but the only difference is you set it to mode 4 instead of mode 6. That truly is the only difference. But we did it without switch support, which is generally more people are confused by that concept. There's no need to be afraid of it. Go ahead and mess with bonding. Anyway, that's this nugget. I hope that this has been informative for you, and I'd like to thank you for viewing.